Hybrid electric vehicle. The steady reduction in the worldwide oil reserves, along with the set emission guidelines, has actually made the demand for electrical vehicles with the fuel economy to be very crucial. The rise in the rate of the world's population increases the demand for vehicles needed for transportation. In countries that are in the developing stage, this rise has become more intense, thereby increasing the oil consumption of the vehicles. Global warming is an alarming situation that has been the tension in so many parts of the world, leading to the development of the strict rules for the emission and fuel consumption. The hybrid electric vehicle is a motor that uses an electrical battery, a thermal and electric driveline coupling device which develops a powertrain and propulsion system. With the transport industries causing about 25 to 30% of the world's total gas emission, there is need to develop vehicles that can operate using an alternative power. A proposed alternative solution is the battery powered electric vehicles. This comes with some hitches such as the charging time, cost, charging time, and driving range. As a result, hybrid electric vehicles propose to tackle the problems of the both conventional internal combustion vehicles and battery powered vehicles. In hybrid electrical vehicles, the motor is driven by converting the energy from gasoline to mechanical energy with the internal combustion engine. They are environmental friendly and cheaper as they consume a reduced amount of the fuel. Hybrid electric vehicle basics. A hybrid electrical vehicle uses an electric motor or generator along with an internal combustion engine, offering high fuel economy, low tailpipe emissions, and the power, range, and convenience for the conventional vehicles. The cutway diagram illustrating the components of the hybrid electric vehicle. Components under hood include from the front of the vehicle a thermal cooling system and adjacent to an auxiliary battery, a DC to DC converter, a power electronic controller, a spark ignited internal combustion engine adjacent to the electrical generator, an electric traction motor in cylinder, and an exhaust system, pipes emanating from the engine area and continuing to rear of the vehicle. Components toward the rear of the vehicle include a traction battery pack, large box, a gasoline fuel tank, larger box, and a fuel filler, fuel nozzle. A hybrid electric vehicle does not plug into charge. Instead, the battery is charged by the internal combustion engine and through regenerative braking. The regenerative braking, the electrical motor or generator captures the energy normally lost during braking. This recover and reuse of the energy results in battery fuel economy without sacrificing the performance. Energy stored in the battery provides extra power during starts and acceleration. It can also power auxiliary loads to reduce the engine idling when the vehicle is stopped. Key components of a hybrid electric car or vehicle. Battery, auxiliary. In an electric drive vehicle, the low voltage auxiliary battery provides electricity to start the vehicle before the traction battery is engaged. It also powers vehicle accessories. DC to DC converter. This device converts the higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary batteries. Electric generator generates the electricity from a rotating wheels while braking, transferring that energy back to the traction battery pack. Some vehicles use motor generators that perform both the drive and regeneration functions. Electric traction motor. Using power from the traction battery pack, this motor drives the vehicle's wheels. Some vehicles use motor generators that perform both the drive and regeneration functions. Exhaust system. The exhaust system channels the exhaust gases from the engine out through the tailpipe. A three-way catalyst is designed to reduce the engine out emissions within the exhaust system. Fuel filler. A nozzle from fuel dispenser attaches to the receptions to the vehicle to fill the tank. Fuel tank, gasoline. This tank stores the gasoline on board the vehicle until it's needed by the engine. Internal combustion engine, spark ignited. In this configuration, fuel is injected into either the intake manifold or the combustion chamber, where it is combined with air, and the air or fuel mixture is ignited by the spark from the spark plug. Power electrons controller. This unit manages the flow of electrical energy delivered by the traction battery, controlling the speed of the electrical traction motor and the torque it produces. Thermal system, cooling. This system maintains a proper operating temperature range of the engine, electric motor, power electronics, and other components. Traction battery pack stores the electricity for use by the electric traction motor. Transmission. The transmission transfers the mechanical power from the engine and or electric traction motor to drive the wheels. What is a hybrid electric vehicle? HEV. The word hybrid means a mix, blend between the two different things. In automotive industry, hybrid is the use to describe the powertrain of a vehicle. A hybrid electric vehicle is a vehicle which is using two energy sources for propulsion, at least one of the energy sources being electrical energy. The vast majority of the hybrid electric vehicles are using combination of petrol, gasoline, engines and electric motors. There are different types of hybrid electric vehicles. For example, hybrid air vehicles, hybrid kinetic vehicles, etc. But in this video, I am going to focus on only hybrid electric vehicles. And this diagram shows the different components: energy source, energy converter, energy source 2, energy converter 1. And black color line indicates the traction power flow, red color indicates the charging power flow, blue color indicates the energy recapturation power flow. From the working principle point of view, a hybrid vehicle is using two energy sources with two energy converters. These laws govern the way a hybrid electric vehicle works. There is a primary energy source 1 and a secondary energy source 2. There is a primary energy converter 1 and a secondary energy converter 2. For a hybrid electric vehicle, the primary energy source is the fuel tank and the secondary energy source is the battery. The primary energy source has much more energy content than the secondary energy source. Energy can be transferred from the primary energy source towards the secondary energy source, but not vice versa. The transfer of energy from the primary source towards the secondary source is done through energy converters. For a hybrid electric vehicles, the primary energy converter is the internal combustion engine and the secondary energy converter is the electric machine, motor or generator. Part of the kinetic energy of the vehicle can be recovered during the braking only by the secondary energy converter and the stores the secondary energy source. Both the energy converters can apply traction torque to the wheel in the same time. A hybrid electric vehicle is using both the internal combustion engine and at least one electrical machine for the propulsion. There are three main drivers for the development of hybrid vehicles. First one, reduce fuel consumption and CO2 emissions. Second one, reduce exhaust gas emissions. Third one, improve vehicle dynamics by increasing the torque and power output. Types of hybrid vehicles. The design of fuel consumption or vehicle dynamics improvement depend on the level of hybridization. A hybrid electric vehicle is a mix between an internal combustion engine and the battery electric vehicle. The level of energy contained in the battery and the power of the electrical machine decide the level type of the hybrid electric vehicle. For more details, the comparison between the hybrid electric vehicle types, and this slide shows the ratio between the different energy sources and the ratio between the different propulsion devices determines the type of the electrical vehicle, hybrid vehicle. So now here is the different types of the hybrid vehicles are and summarized in this particular diagram. And ICE, internal combustion engine vehicle, and fuel source is 100% fuel, petrol, gasoline or diesel, and propulsion device is 100% internal combustion engine and characteristic is conventional vehicle here. And coming to the second one, MHEV, micro hybrid electric vehicle, 99% fuel, petrol or gasoline, diesel, and 1% of electrical energy. 100% internal combustion engine is the propulsion device. The main characteristics of this one, it has the ability to use the battery energy for electrical systems without drawing power from the alternator. It can modify the charging profile of the low voltage battery 12 volts by increasing the charge rate during the vehicle deacceleration. And coming to the third one here, and the MHEV, mild hybrid electric vehicle. And in this particular type of this here, so 80 to 90% of the fuel, petrol, gasoline, diesel, 10 to 20% of electrical energy. 80 to 90% of internal combustion engine and 10 to 20% of electrical motors. The special characteristic of this one is the electric machine can provide additional torque during the vehicle acceleration phases. The electric machine can reoperate electrical energy during the vehicle deacceleration. It has two electrical networks and batteries. A low voltage one 12 volts and a high voltage system is the 48 to 150 volts. It has a DC to DC converter to exchange the energy between the low voltage and high voltage network. It has a high voltage electric machine generally controlled by a three-phase inverter. Coming to the another type, HEV, hybrid electric vehicle. 70 to 80% fuel, petrol, gasoline, diesel, 20 to 30% electrical energy, 70 to 80% internal combustion engine, 20 to 30% electrical motor. The characteristics of this HEV is additional to the MHEV characteristics. The vehicle can drive in EV mode. The high voltage system can go up to 300 to 400 volts. The high voltage battery has a high energy content. The electric machines has higher power output. Coming to the another type, PHEV, plug-in hybrid electric vehicle. 60 to 70% fuel, petrol, gasoline, diesel, 30 to 40% electrical energy, 60 to 70% internal combustion engine, 30 to 40% electrical motor. The characteristics is additional to the HEV characteristics. The high voltage battery can be charged from the grid. The vehicle can be driven in electric vehicle mode up to 50 to 60 kilometer. The high voltage battery has higher energy content. The electric machine has higher power output. And coming to the another type of this one here is PHEV, plug-in hybrid electric vehicle. So in this model, 60 to 70% fuel, petrol, gasoline, diesel, 30 to 40% electrical energy, 60 to 70% internal combustion engine, 30 to 40% electric motor. The characteristics are HEV. Additional characteristics: the high voltage battery can be charged from the grid. The vehicle can be driven in electrical vehicle model up to 50 to 60 kilometer. The high voltage battery has high energy content. The electrical machine has the higher power output. And coming to the another model on REEV, range extended electric vehicle. 80% electrical energy, 20% petrol or gasoline, 100% electric machine. The characteristics are can be regarded as a series hybrid. The internal combustion engine is used only as a power generator. It has additional electrical generator connected to the internal combustion engine. Coming to the another model, BEV, battery electric vehicle, 100% electrical energy, 100% electrical machines, and the special characteristic is full battery electric vehicle. Coming to the another model, FCEV, fuel cell electric vehicle, 50% battery energy, 50% hydrogen energy, 100% electric machine. The characteristics are fuel cell is used as an energy converter, uses hydrogen tank as an additional energy source. So in this particular slide, the observations are an electric machine can be motor or generator depending on the driving situation. When the vehicle is accelerated and the electric machine provides the torque to the wheel, it becomes an electric motor. During vehicle braking system, the electrical machine acts as a generator and converts the kinetic energy of the vehicle in electrical energy and charging up the battery. In hybrid electrical vehicle, the higher the electrical energy and power available, the lower the fuel consumption and the exhaust emissions. This is possible due to the fact that electric power can be used for longer periods of the time and also at high vehicle speeds. Hybrid electric vehicles architectures. From the energy source and propulsion device points of view, a hybrid electric vehicle is a mix between a conventional ICEV and a BEV. In a vehicle powered by an internal combustion engine, all the energy for propulsion is stored in a fuel tank. Through a fuel supply line, the fuel is fed to the engine, which together with a transmission powers the driving wheels. So, in a pure battery electric vehicle, all the energy for the propulsion is stored in a high voltage battery through an electric supply line, and the energy is fed to the electric motor. Together with the transmission powers the driving wheels. There are several ways to combine the internal combustion engine, electrical machine, motor or generator, and the high voltage battery. Four basic hybrid electric vehicles architectures are used. First one series HEV, second one parallel HEV, third one split HEV, fourth one series parallel HEV, hybrid electrical vehicles. In a series HEV, the internal combustion engine never directly powers the vehicle. Instead, the engine drives an electrical generator, and the generator can either charge the batteries or power an electric motor that drives the power to that particular wheels. Series hybrid electrical vehicles is the simpler type where only the electric motor provides all the propulsion power. A downsized internal combustion engine onboard drives a generator which supplements the power voltage, high voltage battery, and can charge it when the state of charge SOC falls between a minimum threshold. The power required to move the vehicle is provided slowly by the electric motor. Beyond the internal combustion engine and the electrical generator, the propulsion system is same as an BEV, making electric motor power requirements the same way as in a BEV. And coming to the advantages of a series HEV are flexibility in parking, packaging, and location of the engine generator set, simple drivetrains, simple control strategies for the internal combustion engine. So now coming to the disadvantages of series HEV are it requires an additional electrical machine. Machine means here is the generator. Without the help of the engine, the electric motor must be designed for the maximum sustained power that the vehicle may require, such as when climbing a high grade. However, the vehicle operates below the maximum power most of the time. All three drivetrain components needs to be designed for a maximum power for long distance, sustained, high speed driving. This is required because the batteries will deplete fairly quickly, leaving the engine to supply all the power through the generator. Coming to the next type, in a parallel hybrid electric vehicles, the internal combustion engine connects to the transmission as well as the electric motor. So both the engine and electrical machine, generator or motor, can supply power to the wheels, switching back and forth as driving conditions vary. In parallel hybrid electrical vehicles, the internal combustion engine and electrical motor can be connected to the drive shaft through separate clutches. Power requirements of the electric motor in the parallel hybrid are lower than that of the BEV or series hybrid because the internal combustion engine complements for the total power requirements of the vehicle. The propulsion power may be supplied by the internal combustion engine, by the electric motor, or by two systems in parallel. Coming to the advantages of parallel HEV are it needs only two propulsion components, engine and electric machine. A smaller engine and a smaller motor can be used to get the same performance until batteries are depleted. For short trip missions, both can be rated at half the maximum power to provide total power, assuming that the batteries are never depleted. For long distance trips, the engine may be rated for the maximum power, while the motor or generator may still be rated to half the maximum power or even smaller. Coming to the disadvantages of parallel HEV, the control complexity increases significantly because power flow has to be regulated and blended from two parallel sources. And another disadvantage is the power blending from the engine and the electric motor requires a complex transmission. Coming to the third type, split hybrid electric vehicle. The engine drives one axis and the electric motor drives the other. There is no connection between the engine and electric components except throughout the road. In the split type HEV architecture, both the internal combustion engine and electric motor can power the vehicle in the same time on different axles. If the battery needs charging, the engine will deliver the necessary torque for both the propulsion and spinning the electrical machine. Machine means generator on the separate axle. Compared to the parallel HEV, the advantages of the split HEV is that it has simple transmission since the electric machine is on a separate axle. The disadvantage is that when the charging the battery, a lot of power is wasted since it is transferred through the road, thus has the low energy efficiency. For practical road vehicles, the best architecture is a combination of the series and parallel HEV configuration. In this particular slide, series parallel hybrid electrical vehicle architecture, the engine is also used to charge the battery and power the drive wheel. Series hybrid powertrain, parallel hybrid powertrain, series parallel hybrid powertrain, and these images are shown in this particular slide. In series parallel hybrid electrical vehicle, a power split device PSD allocates power from the ICE to the front wheels through the drive shaft and the electric generator depending on the driving condition. The power through the generator is also used to charge the high voltage battery. The electric motor can also deliver power to the front wheels in parallel with the engine. The inverter is bidirectional and is used to charge the batteries from the generator or to control the power delivered by the electrical motor. For short bursts of the speed, power is delivered to the drive shaft from the engine and the electric motor. A central control unit regulates the power flow for the system using multiple feedback signals from the various sensors. Use of the engine to charge the high voltage battery should be minimized when maximizing efficiency. Energy is always lost while charging and discharging the battery and during the power flow throughout the inverter. Through the inverter. A series parallel hybrid architecture combines the advantages of the series and parallel hybrid electrical vehicles. For this reason, the most used architecture for the production of hybrid electrical vehicles. Coming to the this slide here is this slide shows the hybrid powertrain system comparison, fuel economy improvement, driving performance, series parallel, combination of series parallel here. So this slide shows here. Thick blue color indicates the superior and white color indicates somewhat unfavorable and medium color indicates the excellent here. So coming to the advantages of hybrid electrical vehicles. Compare with the conventional internal combustion vehicles, a hybrid electrical vehicle has the four advantages. First one, energy loss reduction. The hybrid system automatically stops the idling of the engine, thus reduction of the energy that would normally be wasted. Second one, energy recuperation, the kinetic energy of the vehicle that would normally be wasted as a heat during deacceleration and braking is recovered as electrical energy, which is later used by the electrical motor. And next one is the electric motor assist. The electric motor assists the engine during transient operations, that is the acceleration, thus improving the dynamic response and reducing the exhaust gas emissions. And another one is the high efficiency engine operation. By using the electrical machines as a motor or generator, the engine operating point, torque and speed can be kept in the most economical region. Next one is the pure electric driving. At low speed, the vehicle can be driven in electrical vehicle mode, thus having zero exhaust emissions and fuel consumption. Compared to the internal combustion engine, an electric motor can deliver instant torque and has high energy efficiency. Due to these advantages, the electrical motor can assist the ICE during acceleration phases and also provide extra torque on brief periods of the time. An internal combustion engine can operate in the steady state or a transient state. The transient operations occurs during the vehicle acceleration and deacceleration. The deacceleration phase is generally with the acceleration pedal lifted off. Therefore, in fuel cut operation, no combustion. The vehicle acceleration phase requires the engine to increase the torque and speed, which has negative impact on the fuel consumption and or exhaust gas emissions. In this situation, the electric motor is very helpful because it can deliver part of the torque demanded by the driver and allows the engine to operate more efficiently. Thank you.